Today's mathematics lesson will be focusing on computation and number theory. I am Brittany Henderson.
And I am Tamika Lodge-Fenton. Let's begin.
All right, so today we're looking at number theory, and we're looking at specifically multiple choice questions featuring computation and number theory.
What is computation? Computational skills are the selection and application of arithmetic operations to calculate solutions to mathematical problems.
And number theory is the branch of pure mathematics devoted to the study of natural numbers and integers. It is a study of a set of positive whole numbers, which are usually called the set of natural numbers.
Exam strategies.
All right, so when we get into our exams, the first thing that we want you to know, especially with your multiple choice exams, is relax. Relax, relax, relax. What does this mean? Now, the R here stands for read and reread your questions carefully. Examine every answer before choosing one. So you're going to go over your questions, examine the questions carefully. The distractors are there for a reason. Look for information in tables, graphs, and charts. Always check your work. I know sometimes you're speeding through multiple choice. I know this, I got this. I don't check over. Check over your work. Please do that. X out all answers you know are incorrect. And again, there are lots of answers on your multiple choice paper that are very, very similar. So go through and eliminate them, right? So again, when you're doing your exam, relax.
What do you mean eliminate, Brittany? What do you mean eliminate?
Eliminate, mark it out, get rid of it, dash it away, throw it away.
Oh, that's what you mean.
Yes,
okay,
eliminate.
Right. You had said something though. You said that some of the distractors are very similar.
Yes.
What do you mean?
So with the multiple choice paper, it's so designed that several answers are going to look they're going to be very close. So there's only really one correct answer most times on these papers anyway, because you do have multiple choice papers.
Chemistry does that, don't it?
Yeah, but for this one in math, we're looking for one correct answer, but there are going to be several answers that are very similar. All right? So when I say eliminate, get rid of it. Throw it out. Right? Look for the correct one.
All right.
So now we're going to go into some interesting stuff. We're going to now get into the meat of the matter. We're getting into the math of it. So significant figures, right? Remember,
significant figures?
Why are them significant? What are they?
Hey, they're figures and they clearly have some value.
We need to do something to Tamika today. Yeah, man, they're significant. All right, so let's get into it, guys. All right, so here we have a question. The number 32,747 written to four significant figures. So
let me do it. So, so I'm gonna write 3,274 because I just gonna drop off that 7. Why that can't work?
Well, let's have our friends. So on the screen, right? We see our friends. We have Jenny and Jack. Jenny and Jack is here to help us today.
Okay.
So, you know, when they're helping us out. So when we talk about significant figures, right, we have to start identifying our significant figures from the left of the number. So here we have 32,747, and Jenny and Jack said that we need to start counting significant figures, and in this case, all non-zero digits are significant. So let's go. So here my 3 is significant. My 2 is
significant.
My 7
significant.
My 4
significant.
And how much I gone so far?
4.
4. All right.
So drop off the 7.
Lady, what is wrong with this lady? So no, let's look at the 7, right? What's the value? 7 is 7. What's the value of 7?
Well, it's 7 ones in this number.
All right, so it's 7 ones in this number. And another way we can look at it is, how close is 32,747 to the nearest 10?
Oh, well.
Is it closer to 40 or is it closer to 50?
Well,
tenths?
If you gave me $47, I almost have $50, so it's close to 50.
Okay. So if it is that we're now going to write this to 4 significant figures,
Right.
and my 0 is not going to be significant, then it simply means that my solution in this case is going to be 32,750. Now, we're seeing that? Because my 0 here is not going to be significant, and when I count, it's 1, 2, 3, 4 significant figures.
Oh, if I drop off the 7, I would no longer have 32,000.
No.
I would only have 3,000, so I would change the number altogether. Oh, so when you're looking at significant figures, you have to keep the integrity of the original number.
Yes, so the value has to remain the same.
Gotcha.
Hence why we now have 32,750. But wait, maybe I'm not right. I'm correct. So as you can see, guys, it is 32,750. Look a joke, you know, look a joke in the early morning. All right, so here we have another one. How about this number now? It's getting interesting.
Yeah, what is the number? What is the number? 5,748. That's what? 10,000th? Is it 10? 1, 2, 3, 4? Yes, it looks like 10,000th. That's the place, or you can say 0.05748, just to let you know the digits that we're looking at, to 2 significant figures. Well, you know what I would do already, but let's look at it the way it should be done.
Okay.
All right, so we have this number you want to talk about. You said we count from the left, and it's any non-zero from the left. So those 2 zeros, they're not significant because they're zeros. So 5 would be my first significant figure, then 7. All right, so now 700. All right, so 748. 10, oh Lord, 10/100th is closer to, all right, so that wouldn't make it so, it wouldn't be 8. It wouldn't make it to 8 because that's really not close to 800th. 800 10,000th, or is it? Yes. All right, so that would be 0.057. I'd go with that.
Okay, all right, hold on. So let's ask our friends Jenny and Jack. You know, I told you guys, so Jenny and Jack is here to help us today. Let's see what they have to say. So they were screaming about the decimals, right? And they're right on par. So our answer is B, which is 0.057. All right, we've seen that there. I hope you guys are following so far and you can identify what digits are significant and what are not. Oh boy, so now they're throwing us for a loop. Here it is that we have express 4 and 3/8 as a decimal correct to 3 significant figures. Now, here it is that we have a mixed number and we're asked to now express this mixed number as a decimal and then write it correct to 3 significant figures. All right, so how are we going to go about this one?
All right, so we have to convert that mixed number to a decimal first.
Okay.
So we know we have 4 wholes and all the options give you the 4 wholes in it. Okay, 3/8. How are we going to work that out? We're going to divide 3 by 8 to get the decimal. All right, so we're going to do it on the board. We're going to do it on the screen.
Yeah, man, so here we go. So we've written a number as...
So 3/8 is 37,530 10,000, and so that is when we convert 4 and 3/8 to a decimal. All right, so 3 significant figures. All right, you do it because you come from the left.
All right, 3 significant figures. Okay, so here my whole is significant, so my 4 is significant, my 3 is also significant, and my 7 is significant. So there I have 3 significant figures. However, we need to look at the whole number by itself, right? So 4.37530 is closest to 4.38, right? So our answer would be 4.38.
So we look at the number to the right of the last significant digit, and we see if it's closest to the next place.
Yes.
And we add 1 if it is, and
Yes.
if it's not, we drop it off.
Yes.
Okay.
All right. All right. So now my favorite part. Rounding numbers. Everybody must love this, you know, from grade 7, we're rounding from primary school, we're rounding.
Right,
Every time we go shop, we're rounding.
We're estimating, we're rounding. Yeah.
Yeah, you go to the supermarket. $4.50.
$5 that month.
All right. So, what is the number 2.0847 to 2 decimal places?
You just love the decimal then. 2 decimal places. So I know my decimal, and then 0 is my first decimal place. 8 is my second decimal place. All right, I know I can't just drop it off. I have to pay attention to, so I have my 10th, my 100th, my 1000th place. I have to pay attention to the digit in my 1000th place. All right, and that is not, it's not even halfway. So I'm going to make, it's going to be 2.08.
All right, so again, we're rounding to the nearest hundredth this time around. Let's see. So here we have our number line. So we have a number line now, guys. And again, we're going to place our number on the number line. And as Tamika rightfully said, it is closer to 2.08 or 2 800ths.
Right.
And so my answer is B.
Right.
All right. So this is also a visual that you guys can look at. You can see it on the number line and the placement of the number on the number line. All right, we're still rounding, we're still rounding, we're still rounding. So now we have 3,754 expressed to the nearest 100.
So I would like to look at the digit in the 100th place, in the 100 place. And that would be 7. All right, so we are working in base 10, and every digit is, would have been, if you reach 10 in that place, you would regroup it to the next place, to the place to the, that's left. All right, so I'm in my 100 place, which is 7. Let me look at my 10th place, my 10th place. Why do I'm still in the decimal. In my 10th place, I have 5. 5 is pretty much, 54, 50, all right, okay, 54. I could round that up to 100, It's closer to the next 100.
Okay. All right, so let's take a look again. So again, guys, we're going back to our number line, and we're going to place our number on our number line. So the nearest hundreds we're looking at, right?
Yeah.
So we're close to 3,700 or 3,800. And as you said, we are going.
Brittany, before you move on, Brittany, it's halfway in there,
Yes, and so because it's halfway there.
So why I couldn't just call it 3,700? Oh, conventionally, I guess you don't want to lose your $54. Is money? No, you're 54.
Okay. Well, so it's equidistance between 3,700 and 3,800. But convention has it that when it's equidistance, we tend to go higher and not lower. So hence why we will now round it to 3,800.
Okay.
Right?
Okay.
All right. Woo. Operations on, boy, the decimals, guys.
Jeez.
It's like we're all decimal out this morning. So we're going on to operations on decimals. Alrighty. Oh, wow. Yay.
This is unique.
Yay. We're still relaxing, right? Don't forget, guys.
Oh, yeah.
Relax. So we're looking at the multiple choice questions, and we're remembering one of the strategies we're using is relaxation, because we got this, right? So I'm relaxing.
All right.
So I'm reading the question. I'm rereading the question.
All right. I think we should set this up on the board just to let them see how to make sure they write this down properly. What do you think?
All right. So, firstly, we have several things happening in this question, right? All right. So we're adding, we're subtracting decimals, and we're also multiplying.
Operations indeed.
All right. So Jenny and Jack. I love Jenny and I love Jack. What operations? We tell them already. Right? Addition, subtraction, multiplication. We're good. Jenny and Jack going to come to the rescue. So guys, we have it set up for you. Right? So place value is important.
Most definitely.
As you can see, our wholes are in our ones place, or other digits are in the tenths place, and we have one digit in the hundredths place. So it's important that we maintain that integrity. All right, and then we went ahead and did the addition. So 1 is added to nothing, we get 1. 1 is added to 0, we get 1. And we notice our decimal still maintained, so it's actually 0.11 for our first bracket.
So 1/10 plus 1/100th gives us 1100ths.
Yes.
Okay.
All right. Jenny and Jack got us today, guys. All right. So now we're subtracting. So we have one. We have 1/10 subtract 1/100th.
Ah.
All right. So Jenny and Jack went ahead and,
We get 900.
yes.
Gotcha.
So it's again, ensure that our place values are maintained because that is extremely important. And when we subtract, we got 900th. Now that's not it. So our second bracket resulted in 900th.
Right.
We have 900th being multiplied by, what was it again?
It was 1100.
1100th. So when we multiply 900th by 1100th, dum dum dum. So the answer for this one is D. It would have been 0.0099. And again, guys, relax. Relax. I didn't do it here, but I want for you guys to check over your work. Ensure that you don't just run through this because you're multiplying decimals, you're adding decimals, you're subtracting decimals. You may make a mistake. Relax.
Okay.
All right. All right.
Again. So we have 3 5/10 multiplied by 1 6/10, all divided by 5/10. Looking good.
There's a lot of operations in this one. We're multiplying.
And then we divide.
And we're dividing.
Okay.
Okay.
All right, so let's do, like, Jack, Jill?
Yeah.
What you have to say? All right, so this is a fraction with decimals, most definitely. All right. I also noticed that we're multiplying in the numerator. Let's simplify. All right, let's simplify.
So Jenny is on a path here, guys.
All right, so they have simplified by multiplying 3.5 times 1.6, giving us 5 6/10. All right, and now we're dividing by 0 5/10. All right. What happened? What happened?
You move a little bit swiftly.
Okay. And we would have gotten 11 2/10 to be the correct response. All right.
Okay. Oh, okay.
Yeah.
All right. So now we have another question in this section. Operations on decimals. So now we have 3.3 multiplied by 2.2 plus 5.7 multiplied 2.5. Here it is that we're multiplying and we're adding. And as you can see, there are no brackets. What am I going to do now? No brackets are there, so which one are the first? Do I just run in and do anything? Guys, tell us at home. What we do?
Well, you know what to do. You know to follow the order of operations. You know this.
That's some order of operations.
PEMDAS, BOMDAS, all of those things.
Oh, yeah.
You know that, man.
Oh, yeah.
So,
Okay.
pull back on that.
Okay, I hope you guys know it at home too. So let us draw for the order of operations. So as you rightfully said, we're going to multiply first. So we're going to multiply 3.3 by 2.5. Okay. And then add the two products. So we're going to multiply 3.3 by 2.5 and we get 8.25. Then we're going to add the result of multiplying 5.7 by 2.5 and we're going to get 14.25.
There you go.
Whew, it's a lot of talking, that's a lot of math.
Yep.
Right, so now as you can see, the products, we're now going to go ahead and add the products to get our results. All right, so for this one now.
And Brittany, right away from observation, 0.25 and 0.25 is going to give us 0.5.
Yes.
So if you look at the option, you kind of just want to confirm, but you kind of only have one option.
Look at that. Are we doing something from our relax? We are eliminating some of our responses.
Yes, we
so
are.
right there and then, again, we can check back now, so we can actually do the math. We eliminated some of the answers, right? We can now check back by doing the math and doing the addition, and we know that 8 plus 14 will give us 22.
There you
right?
go.
We just check it back. All right. So guys, our answer is 22.50.
All right. Awesome stuff.
So the last question we left off with was 3.3 multiply 2.5 plus 5.7 multiply 2.5. Right. And we brought up some salient points here. We talked
brackets.
about no brackets.
Right.
What else?
Well, there is more than one operation, so there is multiplication and addition. What do we do first? Because there's no bracket to kind of help guide us.
Okay, and then we talked about order of operations. So whether you're using BOMDAS, PEMDAS, whatever the DAS you're using, we're talking about order of operations. And so in this case, the order of operations stipulates that we first multiply. So we are going to first multiply the first two pairs, multiply the second two pairs, and we're going to find the sum of the products
of the two multiplication.
Right? So we're going to find the sum of the products. So the result of multiplying both pairs, we add them together.
And then you also made a very important point at the beginning of the lesson that you can eliminate some of your distractors by observing what is there. And we realize that 8 and 2500 plus 14 and 2500 would give us 5 tens or 50 hundreds. So right away, there is only one option. We just want to ensure that the 14 and the 8 adds up to 22. So right away, you didn't have to check for the others.
Don't tell them not to check this. Tell them to
check, please.
Yes.
Ensure that the answer is correct.
Yes, man. Remember.
That's what I meant.
Oh, okay. Guys, remember, relax. So after we read and all of these things that we eliminate, we X out, we still like a check, okay? All right, so we checked and we found out that was
Don't
actually
relax
the
to
answer.
sleep though, because you don't want them can relax to sleep and then the exam not done.
So you can't take a nap?
No, miss. Come. Let's get to the next question.
We don't want a nap.
Nap? Come.
All right, so exciting times. This is a problematic area for a lot of students. Fractions.
Oh, yeah.
Fractions.
Students, everybody knows.
Okay, all right. So adults, children, babies.
Everybody don't like
So everybody has a problem with fractions. So let's get into fractions some more. All right.
So, which point on the number line represents 9/7? 9/7. All right, so right there, that's an improper fraction. Therefore, we are talking about 1 and something. All right, so that's 1. How many 7s can I get from 9? 1 and 2 is left, so 1 and 2 7s. All right, so let me find my 1. All right, now I'm going to have to literally count up how much parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look like that, dividing 10. Why you want to give me that? All right. 2/7. So 2/7 is not half of the next whole. So it can be there. And it's not closest to 2. It's R.
Alrighty. Okay. It sounds confident though.
Yeah, but
all right.
It's R.
Okay.
I've got this.
All right. So again, you converted. And let's see. All right. Oh, our friends are talking to us. So Jenny and Jack also want to get in on the mix, and they're saying that you're correct. So it is 1 and 2/7.
Got this.
Right. So we know that we are not looking in the first partition, but we're somewhere in the second partition.
That's right.
Good. All right. Them done talk?
Yes,
Yes,
I'm
then.
done.
Okay, and they have said that you are indeed correct. The answer is R. No, don't be daunted by the fact that you're seeing a number line that not only has numbers, but letters.
Oh, yeah.
So you might see this on the exam. Lord of mercies, what them come with no, why them come with this? Relax.
But it's important to benchmark, because when we converted the 9/7 to a mixed number,
Yes.
1 and 2/7, you have to be able to understand that 2/7 isn't halfway. So it's less than half. So right away you can look at the two options you have within this section, and this is more, W is more than half, right? It's more than half. So
W is closer to 2.
Most definitely.
Right. So we know that, it's closer to 2. Yeah, man. All right. Good.
Next question.
Next. You just get so excited about the fractions. Okay. So now we're going to express 0.12 as a fraction in its lowest terms. 0.12 as a fraction in its lowest terms. What we mean? I see a decimal on the screen. Am I the only one who is fraction come out of this? But guys, we know a few things. We know that another way of looking at 0.12 is saying 12 hundredths.
That's right.
12 hundredths.
It's a big fraction.
Don't it? But we can write it, don't it?
Of course we can.
So that's the same as saying 12 divide 100, don't it?
Yeah.
1200. So
We can't simplify that though?
maybe, because 12 and 100, they must have some common factors.
Yes, they do. They have 4, they have 2. Yes.
Those are enough factors though.
Yeah. All right, you can use a 4. So 4.
So in this case, this is that you just brought up a very important point. In this case, we need to look for the highest common factor. So we need the largest number that's common to both numbers. When we divide them, we have no remainder. Because I know you don't ask me, you don't tell me, but you hear the word factors, and a lot of you scratching your brain. Factors, where that come from again, and I get confused.
You can divide it in the number, man, and nothing is left.
All right. So I keep on forgetting about Jenny and Jack. They're talking to us. All right. And so they're verifying that indeed our answer is C.
So let's show them how we got it to C, though. So 12 hundredths, with the largest factor being 4. Look at that.
1200.
Right, pretty on the board. Right, so 4 divided into 12 goes 3 times. And then 4 into 100 goes 25 times. So look at that. Simplifying that fraction gives us 3/25.
So again, let me just write it out. There's another way because, Miss just said 4. So it means that we're dividing both numerator and denominator by 4.
There we go.
So we're dividing both numerator and denominator by 4. So we're left with 3/25.
3/25.
Yeah, there we go.
Okay.
All right.
So 12 hundredth is equivalent to 3/25, and it's in its lowest term. Oh, thank you.
And then again, guys, you can always check to make sure that your division is correct, because sometimes you divide into 25 because 5 and 4.
Yes,
sometimes you divide and you get 20. Check that.
It's true.
Check it. All right. So integers.
Okay.
Fun times. Ooh. Fun times.
That looks really okay.
This is another scary section for students.
Oh, yes.
When it comes on to integers, negative and positive numbers,
Directed numbers, really and truly.
we don't want to look at it.
All right. So what is the value of -3 subtract -4?
All right. Let's find the value.
All right. So we have -3 subtracting -4. So that means we don't have nothing positive there?
No.
All right. We can put this on a number line.
All right. So here we have our number line, and let's locate. So we're starting at
-3.
All right.
Right. And I'm subtracting -4. All right. So that means I am moving to the, what is this? Left.
Okay.
Okay. Okay.
But because it's opposite of the opposite, we're actually going to be moving to the right.
Oh, so because I'm subtracting negative. All right. So let's see what that
So I'm
looks
actually
like.
moving 4 units to my,
Right.
my left, you're right. It depends on
geez.
how you turn, guys. That is relative.
Let's just face it, so we stay
Okay.
on the same side.
Okay, all right. So so move it to the right, guys.
Right,
Move
there
to the
you
right.
go.
To the right, to the right.
Moving to the right.
Beyonce said to the left, we're going to the right.
That's
okay?
right.
So we're moving to the right 4 units, and our result is going to be 1.
So what happened here is that the negative changed the direction in which we're going. So it became -3 plus 4.
Yes.
Okay.
In essence.
So those two negatives, when they meet, they change the direction.
Yes.
Got you.
So we're at 1, right?
Okay.
No, okay, we've been doing a lot of talking. I hope you guys at home trying the questions. I hope so,
All right. So what is the value of -2 multiplied by, really? By -3 subtract -5?
Okay.
Well, right away I know that some direction changing right there with the -5. All right, no. So
This is exciting.
this is not exciting.
I'm excited. You're not excited? You guys are excited.
I am sure
I'm
they're not excited to see all those negatives on the board.
Is you one feel that way?
Miss, go.
All right. Okay, so what does this actually mean to us? This means we have two groups of opposite -3, basically.
Oh, yeah. That's right.
Yeah. So here's what we're going to do. TV magic. We're going to bring in some algebra tiles. If you've never seen it before,
This is what
they look like. All right, so we're doing the representation of exactly what we have here. So we have let's start off with what we have first, two groups of -3, but again, because the sign is there, we know that we're going to take the opposite of these two groups of -3, which magic. All right, TV magic now work. TV magic, yes! Which means we have two groups of positive 3, which is two groups of +3 is the same as saying 6. So we know that the result of multiplying -2 multiplying -3 gives us +6.
Okay.
Okay. More magic? Okay, so we have the +6. Our equation does not stop there. So now we're going to subtract -5.
And you just told me that that negative in front of my -5 is going to change the direction. So that means now I'm going to add 5.
Okay, yes, so true. Okay. But in the land of algebra tiles, which we're in,
okay,
we need to, as you can see here, we don't have any -5, so we're going to introduce some zero pairs. So we have 5 groups of zero pairs, right? So now I can subtract my -5.
Okay.
Right? So as you rightfully said, the direction changed, and so it's simply that I'm adding 5 to the 6 that I've got, the result that I've gotten. So in total, let's count it up. We have
6 plus 5, am I counting it up? It's 11, miss.
All right, it's 11.
Yeah.
It's 11. See, nice, and yeah, it's 11. Okay. All right.
Indices. Hip hip, hooray.
If we're going too fast, slow us down. I joke, you can't.
This is like awesome. Okay, let's do indices.
All right, so indices.
All right. So the first question is x equal 3 raised to the second power multiplied. What did I just say a while ago? X equal? Did I say x equal? Okay, x equal 3 squared multiplied by 2 cubed. Then x to the fourth power equal. Maybe, we skipped over zero pairs a little bit fast. You think they got it out there? You think we need to explain it a little bit more so that we don't lose anyone? Let's go back to that slide, just a little. Before we go into indices, because all right, so our zero pairs. Okay. So what does our zero pair tells us? Well, what does that term mean, zero pairs? Means when we combine them, we get 0?
Well, in essence, yes. Okay. Because, we have 1 subtract 1, we get 0, which is really,
a zero pair. So if you have, we have +1 here and we have -1 here. If we were to combine them, what it means is each of them will end up with really 0. You're saying 1 subtract 1, 0.
Now we know 0 is an identity element,
Right.
Yeah, okay.
So can I are there any other zero pairs? So -5 and 5 is a zero pair. -7 and 7, zero pair. So once you have both the positive and the negative number, the same value, they form zero pairs.
And they exist all around, sometimes we need to draw, so they're always in, it's not like, okay, we're going to pick it up out of our pocket and they're always around, 0 is always around,
Okay.
Right?
So once you're looking at a number, whatever number it is, and we have both the negative value of it and the positive value, they form a zero pair.
Yes.
Okay, so it could be 200.
It could be, yes,
okay.
yes.
So 200 and -200, zero pairs.
Yeah, man, yeah, of course. So again, they're always around, guys. They're always around.
Everybody get it.
Yeah, man. We talk about TV magic, but it really wasn't really so much magic. It was math magic, right? Okay.
Yeah, man.
All right, so we're back at indices.
Lovely topic again.
Exciting times. Okay, maybe not dance.
I don't know why you're dancing for this topic, and I know these kids out there are like, really? All right, so X. So we have a problem. We have math sentence there where if x is equal to 3 squared multiplied by, oh, I saw 2 cubed, then x to the 4th power is, I don't know.
Okay, so indices. Now let's go back into our memory box and
Right.
let's just remember some of the laws of indices. You know, there's those laws of indices that you did throw away? Come back for them. Right. So now it is, okay, I'm going back to the board.
I like when you go to the board.
Oh gosh. And so,
So-
you know, we want to find out the value of x to the 4th power.
Do you
Now,
have a value for x?
so now we know the value for x, so we have to substitute. We know that x is actually 3 squared multiplied
By
2
2
cube. And this is all raised to the 4th power.
Look at that.
All right. Okay. So we're back to talking about laws of indices.
There you go.
Now what happens, what we call, which one of the laws do you think we need to draw for here?
Well, when a base is raised to a power and then to another power.
Oh, so it's a power to power one.
Yes,
Oh,
that's it.
okay. All right. So let's see what happens. So we could even further break this down to say, whoopsie, you know, 3 squared. Okay, maybe my writing is not so. 3 squared all to the 4th power multiply 2 cube all to the 4th power.
Right.
Right. So I'm hoping that this is a lot clearer for you. So now you can see power to power. Now, what happens here?
All right. So basically you're saying, what is that? 3 squared is being multiplied by itself 4 times. I could have written it out, but that takes forever.
Yeah, we're not
right?
doing that.
So I really, so I don't want to do that because I know a shorter way. So I am going to look at 3 squared multiplied by 4.
Yes. So again, we're going back to the power law, and we know that when we have a power raised to another power, we simply multiply
these powers.
Right. So the result here is going to be 3. So
Squared.
okay.
Is squared?
Yeah, man.
Yeah.
3 squared multiplied by 4. So it's 2 times 4, which will give us
8.
8. Multiply.
Right.
Again, we write back our base. So we're writing back our base, which is 2. And we're now multiplying our powers. So it's going to be 3 multiply 4, which gives us
12.
12. So the product is 12. So we've done this. Let us assess our question. So let's go back to the question. Again, can be A.
No, sir.
It looks like C.
It does. No,
But-
it doesn't. I keep on over pressing this thing.
So it's actually
It's
D.
actually D.
So our answer is actually D. It's 3 to the 8th power multiply 2 to the 12th power.
12th power.
And we saw how we did that a while ago. We used the power law of indices.
So the power law states when a base is raised to a power and raised to another power, you multiply the powers to give you the solution.
Yes.
Okay.
All right. I hope they got that one. Whew. This one
You
is
think
a
you
little
should do one on the
scary.
board again to show them?
No.
Okay.
All right, so this one look a little bit scary now. We know that we're dealing with indices again, but this time,
You'd put in indices and fraction.
so
Who does this?
my base is a fraction, my index is a fraction, and not only is it a fraction, it is a negative.
Okay.
It is a negative power.
But
so it's a
guys-
negative power in my fraction.
But tell them again. Relax.
So guys, relax. We've got this. Relax.
You're going to do well, though.
Yeah, man. So here's what. I'm going to ask for you guys to just take a second, look at this question, relax at home, and do it.
I know you are at home looking at this question. And I know you're probably working it out, don't it, Brittany? I think
Yeah, man. We're telling them to work it out before we come
so
back, right?
Let us just work with you so that you can check what you did at home.
All right. So we're still relaxing. So this part is the check part.
Yes,
Okay.
yes,
All
yes.
right. So
What
here,
does this mean?
a whole heap of
really-
things.
yeah.
So a whole heap of a lot of laws are at work here.
We have a negative one.
We have the negative law of a negative index. We also have the law
Raised
of
to a fraction.
a fractional power. So there are several laws. So there are two laws at play here.
Right.
So here's what we're going to do. Break it down.
Thank you, because
All right, so first let's start off with the negative law. So what
Yes.
does that actually mean? So I can now rewrite a quarter raised to the negative half power as 1 divide 1/4 all raised to the half power.
okay, so you got rid of that negative.
Yes.
So the negative, well, it's not really gotten rid of.
No.
You've rewritten the power without the negative.
Yes,
As a positive.
Yes,
Okay.
because the law of indices states that when I have a negative power, I'm actually dividing
It's
1
actually
by
the
that.
denominator. Oh,
Yes.
right.
All right. So here I've done something.
Or to make it positive, you put it in the denominator's place.
Yes.
Got you.
All right, guys, are you a little bit scared? Okay, let's rewrite it. Let's rewrite it in a form that is more user-friendly. How about
Yeah,
that?
please.
So it's 1 divide by a quarter raised to the half power.
There you go.
Right. Okay. We got this.
No, but go on.
Oh.
Okay.
All right.
Sure.
So let's deal with 1 divided by a quarter.
Yes.
All right. So
You think we can do that? We don't have to go
no.
to the
the powers.
Yeah,
Oh
we
yeah.
have to go to that powers first, because you did tell them the law of indices,
Yes.
and we do the exponent first.
Yes.
So let us do that. Let's find the square root of that.
All right, so we know that when something is raised to the half power, it's the same as finding the square root of that number. So it's actually 1, and we're going to find the square root of this, which will give me,
Couldn't just put that outside there. So
what? Okay, so the 1, it's actually going to be the square root.
okay. Or let's, if we were to take that off,
Okay.
please. We just rewrote the thing in terms of a positive index. All right.
All right, so this is the same as saying, so 1 divided by
quarter.
A quarter is the same as saying 1 divided by 4.
1 multiplied by 4.
Sorry, 1 multiplied
By 4.
by 4 over 1 raised to half. Right? Which is the same as saying 1 multiplied by anything, I'm going to get back that result. So that is going to be 4 to the half power. Right? So any number raised to a fractional power, and in this case, because the fractional power is a half, we're now going to find the square root of this number.
Oh, yes.
So we're going to find the square root of 4,
Which
and
is?
the square root of 4 is
2.
all the way up here. 2. All right. Am I right or am I wrong, teacher?
Boy, it's a little stickler. Let's see what Jenny says.
All right. Jenny says I am right.
it's
Jenny says that I am good. Jenny says that 2 it is. Right. I know this one may kind of throw you for a loop again, because we're not only dealing with negative power, but we're also dealing with fractional power. And as you can see here, mistake can make. So please, and please, and please, check and always relax. Right. So let's go to another one. Exciting time still.
All
so we're
right.
still excited.
So if 3 to the 6th power divided by 27 equals 3 to the x power, then the value of x is, all right.
All right, so now we have an index equation, right? And one of the things that we know about indices is that we always have to have, if we're doing any sort of equation, we have to have everything written to the same base. So it's very important that if possible.
Yes.
So let us go ahead and assess our equation. So now we have 3 to the 6th power divide 27 is equal to 3 to something power. So now we know that we can convert 27.
Right, because 3 is a factor of 27.
Yes, so we can convert 27 to something
To
represent 3 to the power of something.
Right.
So it's going to be 3 to the 6th power divide
Okay, 27. You have 3 times 3 is 9. 3 times 9 is 27.
Oh,
So
look
that
at
would be
that.
3 to the
Third power is equal to 3 to the x. Now,
You're applying another law.
laws come back in and we excited again.
So we're looking at the law of
Laws of
division.
law of indices, and specifically we're looking at what happens when we divide indexes. So here it is that we're dividing two indexes, right?
Well, two numbers that has the same base, raise the powers. Okay.
Yes. So what happens with the index? We simply subtract our index, right?
Yes,
so the
we
law states that we now subtract our index. So it's going to be, I can rewrite it several ways, right guys? So I can rewrite it as 3 to the 6th power subtract 3 is equal to 3x.
No, just to remind them, we're not guessing this thing. If we were to write out 3 raised to the 6th power, expanded form, and then write out 3 raised to the 3rd power, expanded form, you'd have realized that the result would have given you the very same thing as 3 raised to the 6th power subtract 3. So it is just that this is the shorter way to do this.
All right, so this is the shorter way of doing it. Yes, that is true. So my result here is going to be, I'm just simply subtracting my indexes. And so it's going to be 3. 6 subtract 3
is 3.
Oh, okay. Yes. So it's 3. So, and that is equal to 3 to the x, or 3 to the something, right? So there we go. We know the value of x, and in this case, the value of x is simply 3. So we have gone ahead and applied the laws of indices, the division law in this case, and we subtracted our index. Guys, I hope that you are ready for your exam and you are relaxing at home. Don't forget, when we go on our math exam, relax. So that's all the time we have for today.